What if there is a technology that is so revolutionary that Bill Gates said that it is the most important advancement in technology since he first saw a graphical user interface in 1980? We will explore why Bill Gates is so impressed by ChatGPT. Stay tuned. AI can be seen as a continuation of the scientific revolution, which began in the 16th century and transformed the way humans understood and interacted with the natural world. The scientific revolution was driven by empirical discoveries, or the acquisition of knowledge through observation and experimentation, rather than relying on authority, tradition, or intuition. Empirical discovery enabled scientists to test hypotheses, verify facts, and discover new phenomena such as gravity, electricity, and evolution. However, empirical discovery alone was not sufficient for advancing science. It also required scientific understanding or the ability to explain and predict the underlying causes and mechanisms of natural phenomena using theories, models, and laws. Scientific understanding enabled scientists to generalize from specific observations, derive logical consequences, and apply their knowledge to novel situations. For example, Newton's law of motion not only explained the motion of falling apples, but also the motion of planets and projectiles. AI can be seen as both a product and a producer of empirical discoveries and scientific understanding. On one hand, AI is a product of empirical discoveries and scientific understanding as it builds on the scientific achievements and insights of various disciplines such as mathematics, computer science, engineering, psychology, and neuroscience. On the other hand, AI is a producer of empirical discoveries and scientific understanding as it enables new ways of collecting, analyzing, and interpreting data, as well as generating and testing hypotheses, models, and theories. In a recent podcast hosted by Bill Gates, the founder of Microsoft and a prominent philanthropist, he invited Sam Altman, the CEO of OpenAI, a research organization dedicated to creating artificial intelligence that can benefit humanity. Altman has a diverse background, including Y Combinator, a startup accelerator that funded successful companies like Reddit, Dropbox, and Airbnb, and investing in climate-related ventures. In the podcast, they discussed the latest developments in AI, especially the natural language processing capabilities of ChatGPT, one of OpenAI's flagship products. ChatGPT is an AI-powered language model that can generate human-like text based on prompts from users. It can see, it can hear, and it can speak, enabling it to chat with images, voice, and create images. ChatGPT uses deep learning, a branch of machine learning that involves training neural networks, which are computational models inspired by the human brain on a massive amount of data. ChatGPT is based on GPT-4, the latest and most capable version of OpenAI's generative pre-trained transformer model. It has over 175 billion parameters or ways that determine how the model processes the input and output. Bill Gates expressed his surprise at the remarkable improvement of ChatGPT, mentioning his initial skepticism when he first tried ChatGPT a few years ago. He said that he was impressed by how ChatGPT could answer questions, assist with tasks, and generate creative content such as poems, stories, and code. He also acknowledged the mind-blowing progress that OpenAI has made in advancing the field of NLP and the challenge of understanding the encoding behind the impressive performance of ChatGPT. Sam Altman discussed the challenges of understanding AI representations, comparing them to complexity of the human brain. He said that AI representations are the way that AI models store and manipulate knowledge such as concepts, facts, and objects. He explained that AI representations are often difficult to interpret as they are encoded in high-dimensional vectors or arrays of numbers that capture the semantic and syntactic relationships between words and sentences. He said that AI representations are also dynamic as they change depending on the context and the task. Altman said that he was optimistic about gaining a deeper understanding of neural networks, citing progress in interpretability or the ability to explain how and why AI models make decisions. He said that interpretability is important for ensuring the safety, reliability, and fairness of AI systems, as well as fostering trust and collaboration between humans and AI. He said that he expects an increased understanding of neural networks in the next 5 years as more researchers and practitioners are working developing new techniques and tools for analyzing and visualizing AI representations. The future milestones of AI. AI is a broad and diverse field encompassing various subfields such as machine learning, computer vision, natural language processing, speech recognition, robotics, and artificial neural networks. Each subfield has its own goals, methods, and applications, but they also share some common challenges and aspirations. One way to measure the progress and potential of AI is to consider some of the future milestones that AI researchers and practitioners aim to achieve. Some AI experts believe that AGI is possible and achievable within this century, while others are more skeptical or pessimistic. AGI would have profound implications for humanity, as it could surpass human intelligence and capabilities or artificial superintelligence, and pose existential risk or opportunities depending on how it's aligned with human values and goals. Another milestone of AI is multimodal AI, which refers to AI systems that can process and integrate multiple types of data, such as speech, images, text, and videos. Multimodal AI would enable more natural and effective human-computer interaction, as well as a richer and deeper understanding of complex and dynamic environments. For example, multimodal AI could enable conversational agents that can not only understand and generate natural language, but also recognize and express emotions, gestures, and facial expressions. The second milestone is reliable AI, which refers to AI systems that can perform consistently and accurately, even in uncertain and challenging conditions. Reliable AI would require addressing some of the current limitations and challenges of AI, such as robustness, explainability, fairness, and accountability. For example, reliable AI could enable autonomous vehicles to safely and efficiently navigate complex and unpredictable traffic scenarios, or medical diagnosis systems to provide transparent and trustworthy recommendations to patients and doctors. Third milestone is customizable AI, which refers to AI systems that can adapt to the preferences, needs, and goals of different users, contexts, and tasks. Customizable AI would require enhancing flexibility, versatility, and personalization of AI, as well as the collaboration and communication between humans and AI. For example, customizable AI could enable educational systems that can tailor the curriculum, pace, and feedback to the learning styles and abilities of individual students, or recommender systems that can provide relevant and diverse suggestions to user base in their interests and behavior. Fourth milestone is creative AI, which refers to AI systems that can generate novel and valuable ideas, products, and solutions. Creative AI would require expanding the scope, quality, and originality of AI, as well as the evaluation and appreciation of AI-generated outputs. For example, creative AI could enable artistic systems that can produce music, paintings, or poems that are indistinguishable from or superior to human-made ones, or innovative systems that can discover new scientific or technological breakthroughs. The current trends of AI, adaptive computing. One of the current trends that is shaping the development and deployment of AI is adaptive computing, which refers to the ability of computer systems to change their hardware or software configuration dynamically in response to changing data, tasks, or environments. Adaptive computing is also known as reconfigurable computing, as it involves hardware that can be reprogrammed or rewired after manufacturing rather than being fixed or predetermined. Adaptive computing offers several advantages over traditional computing, such as increased performance, efficiency, and flexibility. Adaptive computing can optimize the hardware for specific applications or functions rather than using a general-purpose architecture that may be suboptimal or wasteful. Adaptive computing can also update the hardware after deployment, allowing the systems to adapt to new requirements or challenges without needing new hardware to be installed. And one of the leading technologies that enable adaptive computing is the field of programmable gate array, FPGA, which is a type of integrated circuit that can be configured by the users or the system after fabrication. FPGAs consist of an array of logic blocks that can be interconnected and programmed to perform various functions, such as arithmetic, memory, or control. FPGAs can be reconfigured in nanoseconds, allowing the system to switch between different functions or modes. What do you think about it? Will AI ever achieve human-level intelligence or even surpass it? How will AI impact our lives, society, and the world? And what are the challenges and opportunities that we face as we enter the era of adaptive computing? Share your thoughts and opinions below, and if you enjoyed this video, please give it a thumbs up, share it with your friends, and subscribe to our channel for more.